I just wanted to touch on two topics that are pretty straightforward. We can be really good at these, except we haven't done a lot of this stuff. We mentioned this a long time ago, but I didn't really test over these two items right here called the second fundamental theorem of calculus. You're going to use that when you're doing the derivative of the integral, and also if you have to do the derivative of an inverse function. So this stuff is all on your blue packet. On the second page of your blue packet, it has both things in there that I'm going to discuss. But the second fundamental theorem of calculus, you only use that when you're doing the derivative of an integral, okay? So if you just have an x up there, then all you gotta do is just plug the x in. So if I do the derivative of this integral, it's like I'm just gonna take that x and I'm gonna plug it in right there and I'm gonna be done. If you have a different function though, you're still gonna take that function and plug that in. So you're gonna get f of g of x, but if you got some other than an x right there, you have to remember to times it by the derivative of that function. So you're going to times by the g prime of x. So if I give you an example here, the derivative of an integral, you're going to take that x cubed, plug it in for the t, and then you're going to times it by the derivative of the x cubed, which is 3x squared. That'll be your final answer. If you forget that 3x squared on the multiple choice, that'll probably be there and you'll get that wrong. You just got to remember to times it by the derivative of that actual function there. You can also do that on this one. This is really all you got to know right here. This is just a general case. If it is just an x, it is strictly going to be the inside function right there. You could times it by the derivative of an x, but the derivative of x is just 1. That's why it doesn't matter on that problem. So if we do like a couple more examples on this one, that's a shortcut. The long way is to straight integrate it and then plug in the top and bottom numbers and then take the derivative after that. So let me just, here's your second fundamental theorem of calculus again, straight from your blue sheet. So if you have to do the derivative of the integral, you're just going to plug that in, and then that's that, and then you're going to times it by the derivative of that function right there. So what I'm telling you is if I have to do the derivative of this integral, all you got to do is take the x cubed and plug it in. So x cubed to the 4th would be x to the 12th, and then you times it by the derivative of the x cubed, which is 3x squared. So you're going to get that 3x to the 14th right away. If you do this the long way, notice why this works, all right? If you do this the long way, if you integrate that, you get that easy integral, and then you do your first fundamental theorem of calculus. You plug in the top number, plug in the bottom number, and then you're going to get this x to the 15 over 5 minus 1/5. That's what that integral is. So once you get that answer, you're supposed to take the derivative of that thing. So once you do the derivative, 15 times 1/5 gives you 3. You multiply by the power, decrease that power by 1. You're going to get that same exact answer right there. But see, what they could easily give us, they could give us something that you can't integrate, or that it takes too long to integrate, and you're not meant to do that. So whenever you have to do the derivative of the integral, that's your second fundamental theorem of calculus. And this is just another example of that. So if I have to do the derivative of the integral, I could take the radical x, I could plug that in place for the t, that gives me 1 over 1 plus x, but then I times it by the derivative of that x to the 1/2, so I just multiply by the power, decrease the power by 1, and then simplify it. There's your second fundamental theorem of calculus. So we'll see that occasionally. Just be careful with that. I just want to put that out there because we haven't done a lot of that, but that's somewhere in your chapter 4 notes. And then the second thing I wanted to mention was the derivative of an inverse function. Now, sometimes if they give me an easy enough function, if they ask me to do the derivative of the inverse, I can do my pre-calc stuff first, where I can just switch the x's and y's, solve for y, boom, there's my inverse function, and then take the derivative of that. But sometimes we don't always have that option. Like this example here, I didn't have that option. So the derivative of the inverse, I don't have an example in the blue sheet. That's why I'm going to go over an example right now. But if f is the original function, g is the inverse function of f, when you do the derivative of the g of that inverse function is 1 over f prime of g of x. The way I remember this is the original function goes on the outside. That's the one you're doing the derivative of down there. The inverse function goes on the inside. And so in for inverse, in for inside, the inverse function goes on the inside right there. That's how you do the derivative, which would be like the slope of the curve, the slope of the tangent line of that inverse function right there. So as we look at this one example, that's the same exact thing I just took from the blue sheet there. And here's the problem here, right? It says f is a differentiable function, gives me a few points on f, gives me a couple points for the f prime. The g is the inverse function. So it tells me g is the inverse function, and I want to know what is the derivative of that inverse function at 3. So I'm going to use that formula. So I'm going to go g prime of 3. I'm going to go 1 over f prime of g of 3. So The f is the original. That's the one that goes on the outside that you're doing the derivative of. The g is your inverse function. That's the one that goes on the inside right there. Now, when you do this g of 3, it says g is the inverse of x. So inverse of f. So this is a little bit tricky. So notice that they give us all these extra points that they try to trick us a little bit there. But notice the point 315 is on your f graph, which means, you know what that means for the inverse graph? It just switches your x's and y's around. So if the point 315 is on your inverse graph, on your original graph, that means the point 15.3 is going to be on your inverse graph. So if I had a g of 15 right there, g of 15 is equal to 3, but I don't have a 15 right there, so that doesn't help me at all. That's when it gives me this extra point. If the 0.63 is on your f graph, that means a 0.36 is on your inverse graph. You just switch them, and that means g of 3 is equal to 6, and that's the one that I needed. So g of 3 is equal to 6, and then 1 over f prime of 6. F prime of 6, they give us that is equal to a -2, and then there's your answer there. Baby blue.